We will now continue with our set operations. So we're now given here with a universal set containing the elements 1, 2, 3, 4, 5, and the subsets A, B, and C. So we're asked to find first the complement of A. So if we're looking for the complement of A, we're looking for the elements that are in universal set but not in A. So you have a 1, but there's a 1 in here. There's no 2 in A, so this will be part of our answer. 3, 4, there's no 4, but there is a 5. So that means our final answer is just 2 and 3. I mean 2 and 4, sorry. 2 and 4. So let's have another example. What if we're asked now with the complement of B? So we will look at B and the universal set. There is a 1, but there's no 2, no 3 in B, no 4 as well, but there is a 5. Therefore, our answer would be set containing the elements 2, 3, and 4. Okay, how about C? What if we're asked to find the complement of C? So same process. You have to compare the universal set with C. But looking at our C, C is an empty set. That means all of the universal set, the elements in the universal set, is not in C. So therefore, our answer would be the entire universal set as well. Or you can just write the answer, which is U, because the entire set that you have here is just the universal set. So the complement of C is just the universal set. Okay, now what if there are two or more operations in just one item? So for example, we have the complement of the intersection of B. So as you can see, the parenthesis would be the same as our PEMDAS before. And the complement would look like an exponent. So you have to deal first whatever's inside the parenthesis before you deal with the complement. So first you need to find the intersection of A and B. That's what you need to find first. Recall that intersection is about the commonality between A and B. So looking at A and B, their commonality is what? We have 1 and 5. So as of now, since it's a new set, so it will become braces already. And then we have 1 and 5 inside. And don't forget there is still a complement. So now the complement of 1 and 5, remember when we tried to find the complement of a set, we're comparing it to a universal set. So the elements that are in universal set but not in here are what? 2, 3, and 4. So our final answer now would be 2, 3, and 4. Okay, let's have another one. What if the given this time is to find the complement of the union of A and B? So when we say union of A and B, we're putting them together in one set. So this will become 1, next is 3, and then 5. Check if we're able to consider all the elements in A or B. 1, 3, and 5. 1 and 5. And don't forget, we're still finding the complement of the set 1, 3, and 5. So looking at our universal set, the elements that are in the universal set but not in here are 2 and 4. So that's our final answer. Again, it's 2 and 4. It's because if you look at our given universal set, we have no 2 in here. We have no 2 in our results so far, and then no 4 as well. Let's have another example. What if it's now like this? So how do we read this one? We're asked to find the intersection of the complement of A and the complement of C. So where do we start? Since we have to deal with whatever's inside the parenthesis, you'll begin by finding first or simplifying each. Remember, this would look like an exponent. So in PEMDAS, we deal first with the exponent, not the plus, minus, multiplication, or subtraction. So you deal with the complement first of each set. So what are those? What's the complement of A? We got it already here, so we just have to copy. But remember, we're looking for the elements that are in U but not in A. So that will become 2 and 4 because there is 2 and 4 in universal set but not in A. And then the complement of C, it's empty. That means all of the elements in a universal set. So that's 1, 2, 3, 4, and 5. So now the operation between the two sets is intersection. We're looking for the commonality which are 2 and 4. So our final answer would be 2 and 4. Okay, let's have last set of examples. So for example, if the given is, what if the universal set, we have S E C O N D A R Y, and then you have set A. Remember, set A is a subset of the universal set, so we can come up with N E R and D. So if you notice, it's like an application of English. The unique the letters in the word secondary is our universal set, and our set A, which is a subset of universal set, we can get or spell out the word nerd. That's why it's NERD. And then we can come up again with another subset coming from the word secondary, and that could be the word diary. So DIAR and Y, the letters in the word diary. And then set C is an empty set. So let's try to find, let's say we're asked to find this, the complement of the intersection of sets A and B. That means you begin by finding first the intersection between A and B. So the intersection or the commonality between the two, they have, let's see, there's no N in B, there's no E in B. There is an R, but there is also a D in here. So that would be R and D. But don't forget, you still have to find the complement of the set R and D. So meaning the elements that are in universal set but not in here. And what are those? We don't have an S, we don't have an E, we don't have a C, we don't have an O, we don't have an N, but there is an N, there is a D in here, so you don't have to write that. A, there is an R, and then Y. So this would be our answer for A. Let's try another one. Okay, what if the given is the union or the complement of the union of A and B? So you'll start by finding first the union of A and B, and that will give us D first, D from the diary, I from the diary again, the A in the diary, and then the R in the diary, and then the Y in the diary. So looking at the word nerd, we were not able to consider yet the letters N, and then E is not yet here, but we already have written R and D. And you don't have to write that again. Remember, sets is about distinct elements. So you should not write D twice. Don't forget, you still have to find the complement of this new set from our universal set. So looking at our universal set, compare it, we'll base it from universal set. There is no S, so that will be our S will be our answer in here. There is an E, there is no C. So C will be part of our answer. O, there's no O, but there is N, there is D, there is A, there is R, there is Y. So our final answer would be S, C, and O. Then our last example, we have the intersection of the complement of A and the complement of C. So what we need to find first here would be the complement of each set. So the complement of set A, so looking at it, the elements that are in A are what? Okay, I'll use another color. So we don't have an S. It has an E, no C, no O in the word nerd. There is an N, there is a D, there is no A, there is an R in here, and there is no Y. So that means that the complement of A is S, C, O, A, and Y. And then the complement of C, because it's empty, just remember that would be the entire universal set. So SECONDAR, and then Y. So now it's intersection. That means we're looking for the commonality between the two sets. And that would be what? We have S, there is a C, there is an O, there is an A, there is a Y. So that would be S, C, O, A, and Y. That would be our final answer.